A project can look healthy in a progress report and still be dangerously unprepared for execution. The schedule may be approved, the cost estimate may be polished, the organization chart may be populated, procurement packages may already be moving, but beneath that apparent confidence, critical assumptions may remain untested, interfaces may remain ownerless, long lead items may remain unidentified, and construction may be waiting for engineering decisions that nobody has yet recognized as urgent. That is why a peer review matters. A peer review is not ceremonial governance. It is not a document-checking ritual. It is not a room full of senior people searching for grammatical errors in a project execution plan. A serious peer review asks one uncomfortable question. Is this project genuinely ready to move forward, or are we merely hoping that unresolved weaknesses will somehow disappear during execution? I want you to understand the distinction clearly. An audit checks compliance against defined requirements. A peer review challenges the quality of the project's thinking. It tests whether the execution baseline is credible, whether the major risks are understood, whether responsibilities are clear, and whether the organization has the capability to deliver what the schedule and estimate are promising. The objective is not to embarrass the project team. The objective is to expose failure pathways before those pathways become expensive. A strong peer review begins with a clear synopsis. What project is being reviewed? Why is the review being conducted? What phase is the project entering? What period did the review cover? Who participated? What were the major conclusions? How many actions were raised? Which actions represent extreme, high, moderate, or low risk? If the executive summary cannot answer these questions quickly, the report is already losing value. Senior decision makers may read only the executive summary. Therefore, it must not be vague. It must communicate the condition of the project, the most important enablers, the most serious risks, and the actions required before confidence can be justified. The next requirement is context. The project overview must explain what is being delivered, where it is located, what infrastructure and services are required, what execution model is being used, and which milestone dates govern the project. Those milestone dates are not decorative. Detailed engineering start, statutory approvals, construction mobilization, mechanical completion, commissioning, and startup dates form the skeleton of the execution strategy. During peer review, you must challenge whether these dates are connected by executable logic. Can construction mobilize when the schedule says it will? Will permits actually be available? Will critical equipment have arrived? Will vendor data be incorporated into the design? Will utilities, temporary facilities, and accommodation exist when the workforce arrives? A date without a credible dependency chain is not a milestone. It is an aspiration. The terms of reference must also be explicit. You must define what the peer review is expected to examine. It may need to test the completeness of feasibility and front-end engineering outputs. It may need to examine whether the execution phase has a robust technical baseline. It may need to challenge procurement and contracting strategies, schedule logic, cost estimates, organization structure, resourcing plans, risk exposure, and near-term priorities. Without defined terms of reference, the review becomes an uncontrolled conversation. With clear terms of reference, every discussion can be linked to a decision, a risk, or an action. Now consider the review methodology. A readiness peer review is normally conducted through structured workshops and interviews with key project personnel. The purpose is to combine evidence with experienced judgment. Documents matter, but documents alone do not reveal whether the team understands the project. You need to speak with the people responsible for engineering, project controls, estimating, procurement, contracts, construction, commissioning, HSE, quality, document control, and project management. Ask them how the project will actually work. Then compare their answers. If engineering believes procurement owns vendor data, procurement believes the package engineer owns it, and document control believes the supplier will transmit it directly to the customer, you have discovered an interface failure before it becomes a schedule failure. That is the real value of the interview process. The peer review team should be independent enough to challenge the project, but experienced enough to understand practical execution. The attendees must be recorded by name and role. This includes the peer reviewers, project personnel interviewed, and customer representatives involved. Why is this important? Because findings must be traceable to informed discussions. It also demonstrates that all major functions were represented and that conclusions were not formed from one department's perspective. Now we come to the heart of the review, the findings. The first major area is the basis of the direct cost estimate. Do not ask only whether the total cost appears reasonable. Ask how it was built, which quantities were used, which rates were applied, which vendor quotations support major equipment costs, what assumptions were made for infrastructure, utilities, bulk materials, temporary facilities, labor productivity, logistics, escalation, and contingency. One part of the estimate may be extremely detailed, while another is based on broad allowances with little transparency. That imbalance matters. Weak estimate transparency creates false confidence. If the basis cannot be explained, validated, and owned, the estimate cannot reliably support financial approval or performance incentives. Every uncertain estimate area should be converted into a specific validation action, not review infrastructure costs. Instead, recalculate accommodation requirements using the latest workforce histogram. Validate wastewater capacity against updated peak site population. Confirm logistics allowances against actual transport constraints. Reconcile equipment pricing with current vendor quotations. Assign each action to one accountable person and define a completion date. The review must then examine the EPCM services estimate. Is the estimate aligned with the work breakdown structure? Does it include the right engineering, procurement, construction management, project controls, quality, HSE, and commissioning resources? Does the staffing profile follow the schedule? Are peak resource requirements realistic? Are workshare offices and shared resources clearly identified? Have travel, site support, specialist studies, vendor coordination, and project closeout been included? An EPCM estimate often fails not because the hourly rates are wrong, but because the required work has been underestimated. A lean organization chart can look efficient on paper while quietly transferring unplanned workload into overtime, delay, and rework. The contracts plan must also be tested. How has the project been divided into packages? Are package boundaries technically coherent? Do they create manageable interfaces? Is the proposed commercial model appropriate for the maturity of the scope? A lump sum contract issued against an immature design does not eliminate risk. It usually converts technical uncertainty into claims, exclusions, contingency pricing, and conflict. You must examine whether responsibilities between owner, EPCM contractor, vendors, and construction contractors are clearly defined. You must also test whether bid periods, evaluations, negotiations, approvals, and award dates support the project schedule. The project schedule deserves aggressive scrutiny. Is it logically linked? Does it reflect engineering deliverables, procurement cycles, manufacturing durations, shipping constraints, site access, construction sequencing, system completion, and commissioning? Are approvals treated as real activities or invisible assumptions? Has risk been applied to critical and near-critical paths? Are engineering, procurement, and construction schedules integrated, or are they separate departmental plans that only appear aligned at summary level? A project does not fail because a bar moved on a chart. It fails because a dependency was misunderstood. The review must identify those dependencies. The organization structure is equally important. Are roles and responsibilities understood? Are decision authorities clear? Are interfaces assigned? Are critical functions fully staffed? Do the assigned people possess the required competence? Is the organization available when the schedule requires it? Do not accept an organization chart as proof of readiness. A box with a job title does not mean the function is operational. The review must also assess accommodation, temporary infrastructure, and workforce support where relevant. Workforce estimates influence camps, transportation, catering, sanitation, medical support, security, communications, and emergency response. If peak manpower is underestimated, the consequences extend beyond comfort. They affect safety, productivity, labor relations, and schedule performance. Capital and operating cost estimates should be challenged together. A project can reduce capital cost by creating a lifetime operating burden. Equipment selection, redundancy philosophy, maintainability, energy use, spare parts strategy, staffing, and lifecycle replacement requirements all influence operating cost. A peer review must therefore question whether cost optimization has improved whole life value or merely shifted cost into the future. Project initiation and administration are another major readiness test. Is the project execution plan complete and approved? Are organization charts current? Are responsibilities documented? Are key deliverables identified? Are success criteria and performance indicators defined? Is there a functioning lessons learned process? Are customer expectations understood? Is the design basis complete enough to control engineering? Are the first 30-day and 90-day priorities established? A project entering execution without these foundations may remain busy, but it will not remain controlled. Risk management must be treated as a working management process, not a static register. Has a structured risk review been conducted? Are risks clearly described in terms of cause, event, and consequence? Are mitigation actions assigned? Are target dates defined? Are residual risks understood? Is the risk register periodically updated? Are the major risks connected to cost and schedule analysis? A risk register containing generic statements such as possible delay or cost overrun has little decision value. The review team must identify the real exposure, delayed permitting, incomplete geotechnical data, unavailable construction labor, uncertain logistics routes, immature vendor interfaces, unstable design criteria, or unrealistic commissioning assumptions. Health, safety, and environment must be examined as an execution system. Is an HSE plan in place? Are responsibilities defined? Are customer and contractor interfaces clear? Are reporting and escalation mechanisms established? Are training requirements known? Have subcontractor HSE expectations been embedded in tender documents? Are emergency response, medical support, environmental approvals, and site-specific hazards addressed? Do not measure HSE readiness by the existence of a document. Measure whether the requirements have been integrated into design, procurement, contracting, mobilization, and construction planning. Quality must be reviewed with the same seriousness. Are engineering reviews scheduled? Are inspection requirements defined? Are inspection and test plans being developed? Are adequate inspection resources available? How will nonconformances be recorded, investigated, and closed? How will supplier quality be controlled? Who has authority to accept, reject, or concession non-conforming work? A quality system that reacts only after defects are discovered is not controlling quality. It is documenting failure. Project controls, change management, and document control form the project's nervous system. The review must compare baseline, revised, and forecast dates across engineering, procurement, construction, and startup. It must examine schedule maintenance, progress measurement, budget control, forecasting, and trending. Is reported progress linked to measurable deliverables? Are cost and schedule systems aligned? Can the team distinguish approved scope from emerging scope? Is a management of change procedure active? What happens after design freeze or haze-up? Who approves changes? How are cost and schedule consequences evaluated? How are claims identified and processed? Poor change control is one of the fastest ways to destroy an approved baseline while continuing to report that the project is under control. Document control must also be practical. How are incoming and outgoing communications recorded? How are emails containing instructions controlled? Are meeting minutes issued and closed? Are numbering and revision systems functioning? Are customer review cycles realistic? Are internal discipline checks, inter-office reviews, and supplier document reviews clearly defined? Are hard copy and electronic requirements understood? If the project team cannot reliably identify the latest approved information, engineering and construction are already exposed. Engineering readiness must go beyond percentage completion. Are authorized engineers and approval authorities defined? Are 30, 60, and 90% design reviews planned? Are technical queries, site queries, and requests for information controlled? Are value improvement and constructability reviews scheduled? Are permitting and specialist studies integrated? Is site engineering support planned? Are as-built responsibilities defined? Where work is shared across offices? Are scope splits, interfaces, checking responsibilities, and communication protocols clear? Engineering progress is not the number of drawings issued. Engineering progress is the reduction of uncertainty required for safe procurement, construction, and operation. Procurement review must test the complete supply chain. Is the procurement plan approved? Are customer requirements incorporated? Are long lead items identified? Are bidder lists available? Are commercial authorities and delegation limits clear? Are required on-site dates established? Are vendor data requirements linked to engineering needs? Are expediting, inspection, freight, customs, storage, and preservation plans in place? Have currency exposure, export restrictions, tax conditions, market constraints, and exceptional transport requirements been considered? A purchase order is not the end of procurement. It is the beginning of supplier execution. Construction readiness must then be challenged. Is the construction management plan in place? Is the site organization defined? Are local, expatriate, and specialist resource requirements understood? Are site administration, security, medical services, warehouses, material control, and preservation arrangements ready? How will completion, handover, and system turnover be controlled? Are testing and acceptance plans established? Are operating procedures and vendor manuals planned? Are vendor representatives included in purchase orders with expected schedules and rates? Is the startup sequence integrated with construction? Are lifting studies, transport arrangements, site communications, and subcontracting strategies prepared? Construction cannot compensate indefinitely for late engineering, incomplete procurement, or poor interface management. It merely becomes the place where all upstream failures become visible. Finally, every meaningful finding must become an action. Each action should identify the relevant document or system, describe the finding, assign a risk level, define the required response, name the responsible owner, establish a due date, and record the current status. Avoid weak actions such as consider improving the schedule. Use closure-driven language. Rebuild the Level 3 schedule to include vendor data, regulatory approvals, and system completion dependencies. Validate peak construction manpower and revise accommodation and utilities capacities. Issue the approved procurement plan before release of priority inquiries. Define the engineering work-share interface matrix and checking responsibilities. Complete the construction material preservation procedure before the first major delivery. The responsibility for closing agreed actions lies with the project director and project team. The project sponsor and quality manager provide assurance that actions are being closed properly and on time. They may also help secure specialist or corporate support where the project team cannot resolve an issue alone. But remember this, an action is not closed because somebody wrote "completed" in a spreadsheet. It is closed when evidence demonstrates that the underlying risk has been reduced to an acceptable level. A peer review is successful only when it changes project behavior. It should sharpen priorities. It should expose hidden assumptions. It should force clear ownership. It should connect engineering, procurement, construction, controls, HSE, and quality into one execution reality. And it should give leadership a truthful answer to the question that matters most. Are we ready? Because the cost of discovering the truth in a peer review workshop is small. The cost of discovering it during construction, commissioning, or startup can be enormous. Do not use peer review to confirm what the project already believes. Use it to challenge what the project has not yet proven. That is how you turn experienced judgment into project assurance. That is how you convert findings into controlled action. And that is how you prevent confidence from becoming complacency. File site turn file 0